Hello hackers, welcome back to the 7th project of Rust for Hacker series, and this is going to be the second part. Technically this is going to be the second part of the cross-site scripting scanner. In previous video we did develop a cross-site scripting scanner exclusive for reflectors cross-site scripting, but this one is for finding out stored XSS. The difference between the reflector one and stored one is reflector one doesn't have any persistence, but stored one always have persistence, because it saves in the database and reflect back to the user session. So if you are not familiar with what exactly cross-site scripting or web app security, I strongly recommend you refer the OWASP top 10 web app security guide, so you will get a basic idea of what exactly it is. So let us continue to our project. And I strongly recommend you to refer the previous video of the first reflector scanner, because we are going to use the same technique for this scanner too. Basically the logic is same. The only difference is internal difference, that is the application side difference. It saves in database and comes back to the user session. So it will be persistent for the user session. So whenever the user logs in, it will be there until the user remove it. Until he removes it, it will be there as a payload, so it will work. It will execute every time when the user logs in. But for the other one, the attack vector is different. The malicious attacker has to craft the payload and send the user to make it work. But this one will be permanently saved in database and it will be there. So let's go to actual work. Before moving forward, I'm just strongly recommend to go and visit my Rust for Hacker series GitHub project. In that I have uploaded all the projects that we have done till now. I'm going to reuse the same code that we did previous video, especially for this reflected cross-site scripting scanner. So I'm just copying this one and creating another project here locally. So let me create a project here. Cargo new XSS stored scanner. So it's created a project, cd to that, then cd, okay, not cd, open up our editor, source code editor. I just test this. I'm changing the content with my previous code, reflected XSS scanner. One more thing you have to do is you have to update the dependency file, because we were using two external dependency packages. One was reqwest and the other one was scrapper, and we explained everything on the previous videos, why we used and how to use this one. So now we have the reflector cross-site scripting one. Let me just build it, otherwise it will take some time when we try to make it again. When we try to run it first time. So let it run behind the scene. I hope it will. Okay, so the main thing here, the first thing we have to do is we have to analyze the application. So for that, we should know before attempting what exactly we are going to automate. So in this case, and one more thing you have to keep in mind, that this is not going to be a scanner that is automatically finding out the injection points and injecting. We know where it should be, so we have to supply the parameters and we have to do it. And say one more thing, this is very basic. The main thing is learning Rust and automation. So the main thing here, we are focusing on Rust. Of course, you can if you are interested in Rust and if you are interested in web app security automations, security testing automations, definitely you can go further and develop an app that automatically identifies all the input injection points and then tries your payloads on that. It can be done. It's all about the time that you spend on this. So it's running here. Let it be. Let the project build behind the scene, and let me open this one. yeah, go to the proxy, open the browser, did I click? Yeah, it opened, and let me confirm the IP. Yeah, 179 is my IP, nothing changed, so it's 192. Oh yeah, it is already here. Yeah, it is, we are intercepting it, so I'm just making it off for the time being, because we need to analyze mainly. Let me set this security level to low. We have explained all these things in the previous videos, why we are doing this, and the main thing for us to try to automate this stuff, what we are doing. So here we need to find out this thing mainly, test message and test message. So now we start intercepting, and because we have to find out what are the parameters it needs, and here it says, so you can see this is a post request that is going to this URL. We need this URL name and this parameters name. So the changes that we are going to make on the reflector scanner is okay, let's go to this method. Instead of the reflected, I'm going to make it a stored one. Stored scanner, and the URL is different. The URL is XSS_S for the stored one. And the parameters are different. We have seen 3 parameters here. The first one was txt name. It could be anything, like you can say I'm going to say from my Rust scanner. Let the parameter, the message be there. This is going to be, before that we have to confirm how it works. So for the time being, I'm just sending this to repeater and keep it in here, and I'm forwarding this to back to the application. So how it works is like we just did a test, and test message is coming here. Yeah, this one is because I have already tried this before, so that's why it is showing here. And why it is showing like this, because I tried it at the time the security was set as impossible or high or something. That's why when it has done an output validation, and it removed the script tags from my payload. That's why it's showing like this. Yeah, let me keep it here. So the message what percent we did, it is here, test and test message. And now what we need is, we identified that the message part has option to inject. Even the name is reflecting back, so we can try on both. For the time being, I'm just checking with the message part. So what exactly, we have the name field, but the name of that field is something different. Yeah, it's MTX message or something. Yeah, we are keeping the script that, and on the submit button actually it is btn sign. And if you are first time seeing this one, you may get confused. If you have seen the previous video, it will be easy for you to understand this, because we did explain all these steps on the previous videos, why and how did we analyze the application and find out how the application works, then how did we start automating the stuff. So here we are building request first. Compared to the previous videos, after the previous videos actually I did make changes of this code because I wanted to see the fully qualified URL and then the parameter name, which parameter was affected. For the get request it is doing like this, but for the post we have to change, and this one should not be the reflected one. Should be the stored URL. It is stored URL and the parameters as not query. Actually it should be form, and then we build the request, then we say the fully qualified URL is from that, and again this is not reflected, it should be stored. We are getting the response, and after getting the response we are saving it as XSS stored HTML response. Then we check that whether that has the injected payload or not. So the injected payload, instead of hard coding this, we are trying to fetch it from the payload name. So here the payload name field is this empty x message. The previous one for the reflected one was the name of the payload was name of the parameter was name itself. Here it is different, so it is empty found in parameter, found in this parameter. Even all these things could be dynamically updated if you are trying to seriously developing a fully qualified XSS scanner. So now we have we got all the parameters, and what is this? Okay, I did messed up something while pasting. Response is here. After the response, it's fine. Yeah, this one issue of copy pasting just to save time, because I'm not doing it from scratch, because we already did the basic skeleton for this one, for this reflected one. So basically the stored one has the same logic checking, but the difference is that it's a post request and the parameters will be different. The real hard work of the scanners will be finding out all these things dynamically and injecting the payloads. So you definitely have the basic structure now. You can develop this and you can make a fully qualified scanner from this. And of course it should be multi-threading in real time. We didn't cover the multi-threading till now. We'll be going to do multi-threaded application while going forward. So this one is XSS stored one, and here it is a why is on us in insert mode. Here you can see I'm returning an option string. Option string is nothing. Option is an enumerator. It's always having a sum or none value. if this is finding some, if the injected parameter is there on the response, we are saying that we are returning a string that has fully, it says found in this parameter with a fully qualified URL. So when we are checking it on the main function, we are just matching. We are using a match keyword to get the actual values of the returning functions. Here we are saying it's not reflected, actually it should be stored. If you are not getting any of these options, what we are doing, please refer the previous videos, because we explained a lot about all these things in the previous videos. So I think we did for this one. And one more thing is, we are setting it up with the security level as low programmatically. See, what we are doing is, here, if you are seeing it first time, anyway I'm going to explain one more time. We are setting up the basic URL path and we log in, then we set the security level to low, then we try to find out this one, because this is how the app works. We try to learn the automation steps using Rust. So we learn how the application works with all the parameters, then we are trying all these things. So behind the scene, I think I'm expecting this one is done. So now I can try to run this, and hopefully it should work, because we didn't make any mistakes. See, it is there, login successful, and it found the issue because the security level is low. So let's go here and just confirm it, either by refreshing this one. Let me see, are we on the web suite? Oh, it is intercepting. Let it block. Oh yeah, see, it works. It comes here, you can see a message here, and we set up from the scanner. See the name field, we set it up from the scanner, and the message is actually not showing here because it's a script, and the browser interpret it as a script itself. So if you go to the page, you will definitely find out this one. See the difference between these two. This one was injected at the time the security level was high, and it has that encoding scheme. So it first of all, it removed the script tag, then it tried to encode these characters. See the single quote and other stuff. So that's a basic difference between the high and low level security of this application. So what we can do now, it confirmed that we did this one. So you just try with the different type of security from programmatically from your app itself. So as an example, if you try here, once if you come on the security level, here we have different level of security. Just say it's high. So in high level security, this will not be working. So from scanner with high security, I'm saying, and if I'm going to run it here, it should return with this. Normally it shouldn't be there. It says it's stored found. Okay, why it says, because as I explained in the beginning, this is a persistent attack. So already this there is on the database, and whenever the user accesses this page, this will always have this injected payload. So this should be there. This is working, and our payload is same. So if unless the payload is different, whenever we check in the response, it is getting this payload every time. So the best way to check is clear this, and now try again with the high security, because in program we set it up as a high security here. Now let's try. It should return with no XSS found. Yeah, see, no stored XSS. Why? Because if you come here and refresh this one, you can see there are a couple of precautions they have taken before the output is processed by the browser. So this is done by the application side. They have removed the script tags, and they, as you see previously in the page view source, they removed after removing the tags, they did encode these characters. So block that browser to consider this as a JavaScript. Now it is considered just as a normal text, so it won't get executed in the browser session. That's how it works. You can try, but there are ways to bypass these things by using different type of payloads. The main thing you can try as a next project is try with a different level of security, and with the different payloads try to automate your stuff. So if you want to add more things to this scanner, you combine this both scanners into one application and try with different payloads and parameters. And as the last one, as a big scanner, what we can think is like just try to crawl the application, try to find out all the input injection points, both get and post methods, then try to find out the form parameters. Then all things should be done by the application itself. Then you can make it as a complete XSS scanner. So that's all for this video. We'll be continuing to the project 8 soon, so stay tuned. If you are interested in this Rust programming for hacking series, stay tuned, and if you like it, consider sharing it and with others if they are looking for this kind of program application development series. So yeah, that's it for this video. See you soon with the project 8.